Okay, so today's lesson we're going to do exercise 9J, rate of change. This is the year 11 level of rate of change. There will be on a year 12 level of rate of change as well. So this is treat this as like a foundation of rate of change, and then you need to understand this exercise before you can move on to the year 12 one. The two type of rate velocity and acceleration, but again this is going to be something in terms of year 12 content that we're going to do. So in this exercise we're going to just dealing with the general rate of change, and we're also going to talk about what is the average rate and what is the difference between the average rate and the instantaneous rate. All right, so let's just start with a curve here. Okay, let's okay. All right, so think about this, right? We've got a curve, right? And then just representing any functions here. The average rate, okay, of this, the average rate, so for example, like in the average velocity or the average speed, if you're traveling from one point to another point, then the average speed can be calculated by finding the distance in between and divided by the time it takes. So if I want to find out what is the average rate between these 2 points, we can call this as A, that's B. Then the rate will be the difference between A and B, okay, for example. So for example, we can call this as T1, that's T2, and that is let's use a different letter here. Oops. All right, let's just using the distance. Okay, so that's the distance 1, that's distance 2. Okay, so imagine if that's just equal to the distance or displacement, and that is the time. Okay, so there are two different rates we're going to talk about. All right, the first one is the average rate. The average rate is the difference between it's like you finding the gradient of this curve here, this line here, the gradient, right? And then the gradient is like you finding the difference between the y and divided by the difference between the x. Okay, that is the average rate. So x2 minus x1 over t2 minus t1. That is the average rate. Okay, in certain question that could be just the average speed. Okay, the next one we'll talk about is the instantaneous rate of change. So it's like in that particular moment, all right, if you're driving, for example, at that particular moment, what is the speed, okay? That is called instantaneous rate. Now, you need to remember this, instantaneous rate always change when the time changes. So it's really hard, like in reality, that you actually know what is your instantaneous rate at that particular moment, because it's always, subject to change as well. So instantaneous rate means for example, at particular time T3 here, at that particular point, I want to know what is the changing speed, or what is the changing certain things, or changing rate. So in that case, we're basically finding the gradient of the tangent. Okay, gradient of tangent. So if you think about instantaneous rate, is also representing the gradient of tangent at a certain point on the curve. Alright, so I hope you understand this. And an instantaneous rate, if we're talking about a gradient of tangent at a certain point from the previous exercise, we've been doing this before, alright? From the previous exercise, it's about a derivative. So it's about to differentiate the function x, okay? So differentiate the function x over the time t. Okay, now I know sometimes the student get confused. Usually we just write dy over dx. How come this time becomes dx over dt? Now x just representing a function in terms of time, so it could be like dq over dt, dp over dt. The population changes, the rate of the coronavirus, increasing. That's the dp over dt. All right, the population that got infected. That's what an instantaneous rate, all right, is about. Okay, so in this exercise, it's all about, the average rate and the instantaneous rate. The question itself is actually pretty easy. It's not hard at all. So I'm going to select a few questions to go through with you guys, and it should be enough to cover, everything in this exercise. All right, so let's have a look. Exercise 9J. All right, so how about we do question 5 first? Okay, exercise 9J, question 5. Right, so question 5 it says the volume V liters of fuel, all right, in a tanker, T minutes after it has started to empty is given by this formula. All right, so we'll write on the formula. The volume is equal to 200, oh, not 2,000, 200 times by 400 minus T squared. Initially, the tanker was full. Okay, so this is an initial condition. So I'll write this one down straight away. When time is equal to 0, Q amount is going to be the full amount. All right, but do we know what is the full amount equals to? The volume V litres of fuel in the tank 10 minutes after is given by this. Okay, we don't know. Okay, anyway, looks like it's just Q is equal to a full amount. All right. So find the initial volume of fuel in the tanker. All right, so the first question, initial volume. So to find initial volume, we need to sub T equals to 0 into the above equation or function. So therefore, Q is equal to 200, 400 minus 0, which is equal to 200 times by 400. So that's pretty easy. That's 8. That's 80,000. All right, so that's 80,000 liters, and that is the initial amount. So in that case, we can change that initial amount to 80,000 liters. All right, question B. Find the volume of fuel in a tanker after 15 minutes. Okay, so it's another substitution question, as you can see here. It's really simple. So now we're going to substitute when T is equal to 15 minutes. Now, do pay attention to the unit. For the question, it mentioned T is in terms of minute, so therefore I can substitute 15 inside. If in the question it says seconds, you just need to make sure you change the unit around. So Q is equal to 200, 400 minus 15 square. Okay, so after you use your calculation, that should gives you 400 minus 15 squared times by 200. So that's 35,000 liters. All right, so question B finished. Question C. Find the time taken for the tanker to empty. Empty means there is nothing inside, so which means substitute Q equal to 0 to solve this equation. So that's a really simple question here, as you can see here. So therefore, T squared is equal to 400. T is equal to plus minus 20. But you don't need to do minus 20, since the minute or time is always positive here. So 20 minutes later, the tanker will be empty. Question D, okay? Now we need to show dV over dt, differentiate the function with respect to t, is equal to minus 400t. Hence, find the rate at which the tanker is emptying after 5 minutes. So we need to find the instantaneous rate at time equals to 5 minutes, and then we also need to show dV over dt is equal to negative 400 here. All right, so how do we show that dV over dt? We need to differentiate the function. All right, so we start with the velocity of not velocity. The volume is equal to 200, 400 minus t squared, and now I just changed the q to v because we need to differentiate this time. So now we expand it. All right, let's just expand 80,000 minus 200 t squared. Therefore, dv over dt, differentiate the volume with respect to the time, is minus 400 t. Okay, and then the question asks us to find the rate when the time is 5 minutes. Okay, so at t equals to 5 minutes, that instantaneous rate of changing volume is negative 400 times by 5, which is minus 2,000 liters per minute. That negative, it's extremely important. That negative tells you the water is sort of like going away instead of adding to the tanker. So it's like leaking or empty. Make sure you put the negative there. Okay, so we've got a negative rate, means we are losing the amount of water in the tank or amount of liquid in the tank. Okay, that's all. So that's how we do question 5. So it's pretty easy. All right, so now let's look at questions where we have some sort of graphical question there. Actually, before we move on to a graph question, we probably can just do another question that's a bit interesting. So let's have a look at question 7. Okay, question 7. Now the question says, on the share price pay of the Eastern Bank 2 years after it's opened on the 1st of January 1970 was pay equals to, alright, so I don't need to know any other information about apart from this function here, which is more important. What is the initial share price? Okay, so what is the initial share price? Initial share price means 1t equal to 0. So the price is going to be 0.4 times by 0 square plus 4 times by 0 plus 2. So therefore, the share price is $2. Okay, that's the initial share price. Question B. What was the share price after 1 year? So 1 year later, so when t is equal to 1. Now, again, be careful. We need to look at the time. T is in terms of years, as you can see here. So it's fine that we substitute 1 inside. So it's very important about a unit. If the units are like it's in terms of amounts, that you have to change it into 12. So P is equal to negative 0.4 plus 4 plus 2. Okay, so that becomes $5.60. That's the share price after a year. At what rate was the share price increasing after 2 years? So at what rate? The question asks you for the instantaneous rate after 2 years. So, all right, so what we need to do is dp over dt, find the rate with respect to time. That's negative 0.8t plus 4. All right, and then at t equals to 2 years later, the instantaneous rate is negative 0.8 times by 2 plus 4. All right, so that becomes 2.4. Okay, so the rate is $2.40 per year. That's how much is increasing per year. Now, please remember the unit. If we're talking about the rate, we are talking about the rate of increase. The unit is actually in terms of like per year, the rate units. Don't just write $2.40. Okay, so question C finished. Question D, find when the share price was stationary. Now, the word stationary tells you that there is no change in rate, which also means the derivative is equal to 0. Sorry, we let the dp over dt equals to 0. So therefore, that's negative 0.8t plus 4 equals to 0. So there is no increasing in rate or anything. So therefore, that's 4 divided by 0.8, which is equal to 5. So 5 years later, or at that instant, right, when t equals to 5 years, the share price was stationary. There is no increasing. All right, that's question D. Question E, explain why the maximum share price was $12 at the start of 1975. Okay, now I want you to think about something. All right, so from question D, we already know that share price becomes stationary. It's not increasing anymore when t equals to 5. So think about this, right? Previously, the share price is here. It's increasing, and then it stops at that point. It becomes a stationary point, and then obviously it's decreasing. All right, so at that point we're going to have a maximum share price, right? So the question now asks us to find out why the maximum share price was 12, and then it is at the start of 1975. So the question was starting like 1970. So 5 years later, so 1975, that's obviously makes sense. We just need to find out what is the share price at t equals to 5. So it's pretty easy. We substitute t equals to 5. So we'll get p times by 25 plus 20 plus 2. Hopefully, after we did a calculation here, we will end up with $12. All right, let's see. 25 divided by 0.4. Well, actually, 25 times by 0.4. That's negative 10 plus 22. So the answer is $12. Okay, and then this is the starting of 1975. All right, seems you're adding 5 to the year of 1970. Okay, all right. So this is question E. Question F, explain why the rate of change of price decreases at a constant rate. Why the rate of change of price decreases at a constant rate. Okay, decreases at a constant rate. Now this is a bit tricky and sometimes students get confused. So I'm going to show you how to do question F here. So first write down the P. Okay, we do P dash here. Let's do the P double dash. Okay, all right, let me explain to you what's going on. Now this function is change of share price. Okay, that's the rate of change in share price. Now what is this function? That is the derivative of the rate of the change of share price. So it's the rate of changing. Okay, it's like, the second derivative is like in the sort of acceleration, whether the particle is increasing speed at increasing rate or increasing speed at decreasing rate. I hope you understand this kind of idea here. All right, so at the moment, as you can see, the rate of changing the share price is negative here, which means the rate of changing share price is at decreasing rate. That's the reason why, okay? So it's decreasing at a constant rate here. And there's also a constant number. So decreasing, okay, at a constant rate. It's not the share price is decreasing the constant rate. It's the rate of changing the share price is decreasing constant rate. Let me know if you don't understand this kind of idea. I'll explain to you again one more time. Okay? Just please remember this. That is the share price. This is the change of share price. And this is the rate of change of the share price. Okay, all right. The last one is question G. The directors decide to close the bank when the share price fell back to the initial value. When this happens. All right, so we just need to find out what is the initial values, and we need to find out the time when the initial values is less than 2. Okay, so it's actually not that hard to do. So question G. A couple of things you need to understand here is what is the best way to do this question. Okay, so for example, in order for us to do this question here, you need to understand something here. Is that is a quadratic, right? It's a parabola. So if you think about this as a parabola, this is a concave down parabola, something like this, all right? Obviously, I don't know about the x-intercept, so that's something like that, all right? So what we're basically doing is we need to find out what is this point is. All right. When this point, once we know this point, then the share price is actually fall after. As you can see, when the time increases, the share price is fall back to the initial value. So we just need to let the initial value equals to 2 and find out the time, and we know exactly after what certain time the share price will fall behind to this initial value. So let P equals to 2. We solve this equation. Okay, we take the t out. We solve this equation. So when t equals to 0, which obviously this is initial time, the share price is $2. And then we solve for the second one. All right, and it's 4 divided by 0.4. That's equal to 10. So that's 10 years. All right, starting from 10 years later, at 10 years, the share price goes to $2 again, and then obviously at 11 years, the share price go after it's going to be below $2. All right, so 10 years. Okay, so when did this happen? 10 years later or 1980. All right, so that's the question 7. Now let's just do one more question that's in terms of a graph, okay? So you understand what's going on with this graph here. So I'd like to use question 10 as an example to show you a graphical sort of question. Question 10. All right, so have a look at question 10. The graph to the right shows the share price. Oh, it's a share price again. Okay, that's a share price. So horizontally is the time, the vertically is the share price. The question I asked, the supplier's T months after the 1st of January. Okay, good. So it's in terms of amounts again. So first question here, A. When is the price stationary? Not increasing or decreasing? So stationary means the turning point. We've got 2 turning points here. So let's just read from the graph. When T equals to 2 and when T equals to 6. Okay, and that's months. Question B. When is the share price maximum and when is minimum? So share price is maximum when t is equal to 6, minimum when t is equal to 2. That's pretty, simple as well. Once the price increasing and when is decreasing? Now, if you look at a graph, increasing, the share price is increasing from 2 to 6. So when the time is actually between 2 to 6, the share price is increasing, decreasing. Oops. Decreasing when the t is in between 0 and 2, and also the decreasing when the t is greater than 6. All right, next, when is the share price increasing? All right, we've done that. Question D, when is the share price increasing most rapidly? Okay, increasing most rapidly means we need to find the tangent, and we need to know the gradient of tangent must be, what should I say, must be the highest. So let's have a look at this point here. That point will be the most steep, gradient, or most steep, tangent. So at time when t equals to 4, okay, that is the steepest. All right, so when t equals to 4, question D, when t equals to 4, the share price is increasing at most rapidly. All right, when is the share price increasing at an increasing rate? Okay, that is a very interesting question here. Increasing at increasing rate. All right, so firstly, we need to understand that the share price is increasing from 2 to 6. It's increasing here. Okay, however, it's increasing at increasing rate only when it's, only when, let me change that. Okay, only when it's from 2 to 4. All right, just because it's concave up here, so it's still increasing at an increasing rate. From 4 to 6, it's actually increasing, but increasing at a slower rate, as you can see. All right, so it's like, let me just draw this for you. It's like we have, three different ways of increasing function. That function is increasing, it is increasing, that's increasing. Okay, this is increasing at a constant rate. Okay, this is increasing at, is that increasing rate? Yes, increasing, increasing at increasing rate. And then the last one here is increasing at decreasing rate. All right. Now, how would you know which one is which at this stage? All right, it's very, very simple. All you have to do is pick 2 points and draw the tangent, and you look for the gradient. Okay, the gradient of the first one is greater than the gradient of the second one, then it's increasing at decreasing rate. Pick a point, pick another point, look at the tangent here. That tangent gradient is less than the tangent gradient there, so that's why it's increasing at increasing rate. All right, so therefore, in order for us to solve this question, when is the share price increasing at an increasing rate? It is actually between 2 to 4. All right, last one, sketch the possible curve of dp over dt as a function of time. So I'm just going to sketch on the actual textbook, okay, since we have the graph here. All right. So we need to sketch the derivative sort of function, and eventually I will teach you how to do that later, but right now, let's try. Okay, so let's have a look. All right, the function is decreasing at this point. Now remember, this is a stationary point. So the stationary point, it must be 0 for the derivative. So we've got 2 zeros here. That's a stationary point. Now this part of function is decreasing. So if you look at this part of function here, is decreasing here, which means if the function is decreasing, then the derivative must be a negative, right? So it's negative. The function here is increasing, okay, so it's going to be positive. Then it's decreasing again, so it's negative again, Okay, now it does make sense. All right, this looks like this is a polynomial degree of 3 function here. So degree of 3 polynomial function, that it's a quadratic, which is degree of 2 polynomial function. And then later, next exercise, next chapter, we're going to talk about polynomials, so you will understand a bit more about this. Okay, but this is what graph will look like. Again, you can have a slightly different graph, like going this way and that. That's fine as well. We're only looking for the general shape of this graph. Okay, all right. So thanks for watching it. This is the rate of change for exercise 9J. You should be able to do the rest of the question as usual. Let me know if you find certain questions too hard to do, and I will do the question for you. Thank you.